So sometimes you're dealing with questions where you've been given that there is a continuous random variable, let us write it here, x, which is a continuous random variable, right? That follows the normal distribution with a mean of 21. So let's just write it here. Let's just use the group mu. That's going to be 21. And a standard deviation, which is going to be the square root of 9 or otherwise 3. Don't forget and don't make the mistake that we do it often many times. The 9 is the 3 squared, the standard deviation squared, or otherwise the variance rather than. So you have to square that number, unless if you see that x follows the normal distribution with mean of 21 and then 3 squared, then it's going to be easy to identify that that's going to be your standard deviation squared. So I hope that makes sense there. Anyway, there are questions like that you have not been given the value for which the continuous random variable needs to be above or below. Like here, for example, you have the probability of x smaller than x, such as the probability to be 0.8. Now, kind of weird to deal with it. So what I'm going to do, I'm just going to draw a bell-shaped curve, right? And I do know the mean here in the middle is going to be like 21. And all I want is the probability, so it's smaller, or it's smaller, the probability of a number x, such as the probability to be equal to 80%. So let me just work with that a little bit. I will assume I want the probability to be 80%, so I'm going to shade definitely the half of the bell-shaped curve that I have in front of me, and then roughly another 30%. So if this is 80%, right, for what value, that is the question, for what value x the probability distribution is going to have if the probability is going to be 80%. So I know it's out of context and it might be a little bit confusing, but all we're trying to do is just to find that value of x. So given the mean and the standard deviation 21 and 3, that's my that's the bell-shaped curve, and this is what the x, the random variable, does. And I want to find out for what value of x there's going to be an 80% chance for success or whatever is happening. So in this case, we use something that is called the inverse normal distribution, and then we write inverse. Well, actually, let's do it on the calculator first. So menu, then you go into probability, then into distributions, and we want the inverse normal, option 3. And that would come up with that sort of box, and it says, what is the area? So the area, right, corresponds to 0.8. Where do I see that? Well, I see that on the question itself. It just says that the probability that you want you to calculate, I want to calculate for what value of x, I'm going to get a probability of 80%, right? Or otherwise, area of 0.8, because don't forget that the total area under the normal curve or the bell-shaped curve, the total area, not the one I've highlighted, but also the rest of it, they always add up to 1. So the area here is going to be 0.8. Then the mean is going to be the 21, which is the mean that we're working with. Then the standard deviation is going to be 3, because 3 squared, that's going to give you 9. We discussed about all of those things. Press OK. That will give you the answer, which is 23.5249. So that would give me that value of x. That's what we get. And so let's write down what we put into the calculator, because that's part of your working out. Otherwise, we won't know what parameters you've used. And that will give you 23.5249. I would write everything that I see in my calculator and then round it to 3 significant figures, 23.5, and then 3SF right next to it, and that would be the end of it. And then equally, you can do the part B. by, let's draw another shape so we see kind of like, you know, what that means. That's my normal curve, and I want a value of x for which the probability above is going to be like 0.4, right? So this is the 0.5 in the middle, which is like 21. They want a value of x such as their probability to be 40% for that specific value of x or above. So I'm guessing that a nice way of putting that, it would have been, if there is a value of x, and that's the one you have to think about it, and let's put it here, where the probability it will be 0.4 above, then essentially the area that I'm going to calculate is going to be the 0.6. And that's an important part to take into consideration. So what I will calculate is not going to be the number for which, for what value or above I get the 40% of the 0.4, because the way that the normal distribution works, imagine you are like scanning from the left and you go all the way to the right. So I'm going to calculate the probability, right? Or I'm going to calculate the value or the value of x for which the random variable it's going to be equal to 0.6. And I'm going to go through the same process that I did before. And I can copy that because it's the probability with the same characteristics. And all I want is not 0.8 this time as the area under the curve. I want a 0.6. The rest of the characteristics remain the same because nothing has changed. Press enter. That should give you 21.76. So that would mean that x is equal to 21.76, which is, to three significant figures, 21.8. 3SF. That's the kind of question where we've been given the area under the curve and you're trying to find the corresponding value of x for which that happens. This is the inverse normal distribution. And then I should have written that here too, but I didn't. So let's write it with red because that should have been present too. So the inverse normal, which is the parameters I put into my calculator, 0.6, 21, 3, and then that will provide you with the answers you see underneath. That's it.